Okay, we are given this differential equation with this initial condition, and we are going to use the Euler's method with step size 0.02 to approximate y of 0.08. And now here we go. First, let me just write down the formulas for you guys. We need to have the x values. Now we'll just put an xn for that. And then we also need to have the y values, namely yn's. And this right here is the most important part. You have to remember, we need the previous y value first. That's yn minus 1. And then we are going to add h times f of xn minus 1 and yn minus 1. So what this means is, you look back to your differential equation, the right-hand side is precisely your f of xy, right? And of course, based on this, you know x0, the initial value, is 0 for x, and then the y will be at 1 to begin with. And h is, of course, 2, right? So this right here is actually the setup, and now here we go. Let me write down x0 equals 0, x0 is 0, right? And then y0 is equal 1. So that's our starting. And now, to get the next x value, you just go ahead and just technically you should do xn minus 1 plus h. So you just pretty much keep adding 0.02. So the next one is x1, which is 0.02, like that. All right, y1, this right here. You are going to look at the previous y value, which is 1, and then you add h is 0.02, and then you multiply by f of the previous x and y value, right? So you are going to look at the previous x and y values, put them into here. So I'll just put the parentheses. You put 0 into sign, and then you are going to add 2 times 1, like that. So that's pretty much the idea. And of course, just use a calculator if you would like. This is not that bad at all. You get 1.04. And now you pretty much just continue the process. Next one, x2, you just keep adding the h, right? So you get 0.04, and then y2 is going to be the previous y value, which is 1.04, and then we add the h value, which is 0.02. And then we're throwing this and that into the f, which is x and y right there. So we get sine of 0.02. And then we are going to add 2 times this, right? Because you put this into the y over there. So 1.04 right here. And now, if you do that, you will end up with 1.0820. So I'm just doing this up to the 4th decimal place right here, right? So I'm looking at the numbers, of course. Yeah. And then I will just continue. x3, this is equal to 0.06. And then you just go ahead. y3 is equal to the previous y value, which is 1.0820. Well, just the 0 doesn't matter, you know that. And then plus, again, h is 0.02. h doesn't change throughout the whole process. And then sine of the previous x value, which is 0.04. And then we add 2 times the previous y value, 1.0820, like this. And again, I challenge you guys, if you guys you can just do this in your head, but I cannot. I'll use a calculator. We'll just look at the answer that I already prepared. 1.1261, right? One more, because you see, we want to end up y of 0.08. So the x value for this one is going to be precisely equals 0.08. And then y4, again, put down the previous y value, which is 1.1261. And then, again, you add the h, which is 0.02, and then times sine of the previous x value, which is that. So just putting there 0.06. And then you add 2 times the previous y value, which is 1.1261, like this, right? And in the end, you will get approximately 1.1723, right? I'm just using these 4 decimal places for it. So based on this, we are saying y of 0.08 is approximately 1.1723. So this right here will be the approximation based on the Euler's method. And of course, I know a lot of you guys would like to know like how to solve this differential equation from scratch. I have that video already for you guys, so be sure you guys check the link in the description if you haven't seen that already. And of course, let's compare the values right here, right? So I'll write down for you guys. The truth is y of x, y as a function of x, this is equal to -1/5 cosine x minus 2/5 sine x, and then lastly we have plus 6/5 e to the 2x. And then if you put in 0.08 into all the x by using the actual solution, let me tell you y of 0.08, again, just let x equal to this 0.08, and you actually end up with 1.1769, approximately speaking, right? So this is the actual solution, and this is our approximation. As you can see, it's actually pretty close, right? That's it. Leave a comment down below and let me know if you guys have any questions. If you guys are new to my channel, be sure to subscribe. Thank you guys so much, and as always, that's it.